Hi gang, I hope you take a minute to watch this video on how to solve this problem that we started in class and you guys typed out the answer. So I wanted to show you the way that I did the problem and hopefully that helps. So when you go through this question, you kind of underline the important things and kind of start making a list of the information that's given to you, right? So you can plan out what you're supposed to do. So the mean molar mass of the atmosphere at the surface of Titan, Saturn's largest moon, is 27.4 grams per mole. The surface temperature is 93.7 Kelvin and the pressure is 146.7 kilopascals, assuming ideal behavior, right? So that automatically tells me gas laws. Calculate the density in grams per liter of Titan's atmosphere. Okay, so let's kind of look at this and walk through the information. So mean molar mass, so average molar mass of the atmosphere of the surface of Titan is 27.4 grams per mole. So molar mass of all of the gases on the surface of Titan is 27.4 grams of atmosphere divided by 1 mole of atmosphere, right? So that's the molar mass of all of the gases. Now the surface temperature of that atmosphere is 93.7 Kelvin, okay, and the pressure is 146.7 kilopascals. Okay, and I know that if I'm going to use the ideal gas law, because assuming ideal behavior, so PV equals nRT, so assuming that, I'm going to have to get the right units. So right away, my kilopascals, I'm going to take and convert that into atmospheres. So I know 100.325 kilopascals, and I looked this value up. You do not have to have this memorized. Equals 1 atmosphere, okay? And so that's going to equal 1.4622 atm, okay? And so here I've got 4 significant figures. Here I used 4, 5, 6 significant figures. So my answer here, I write 4 significant figures, and then I put that little one so that it kind of helps me keep track of my calculations, okay? Now I want to calculate a density, so I need to know the density of Titan's atmosphere, which is grams of atmosphere over liters of atmosphere. Right? So that's what I'm trying to figure out. And since it says ideal behavior, I know that I want to use that ideal gas law. Well, grams and moles are kind of similar, right? And so I know that I need this N, and then the liters is my volume. So those are the two kind of variables that I'm going to solve for. So if I can get this equation and rearrange it so that I have N over V, and that's going to equal P over RT, right? So I've just taken and divided the volume by the volume and put it over here, and I've divided the RT and put it over here, right? So I've got N over V equals PRT. Like a party. Anyway, so if I solve for this, this will give me moles per volume, right? And then if I have moles per liter, I can use this molar mass to convert from moles to grams. Okay, so that's my plan, is to use PV equals nRT in this arrangement to get me moles per liter, and then I'm going to use the molar mass to go from moles to grams. Okay, so I'm going to go on the next slide and use these numbers that I calculated in this formula. So I just have the same question on top, right? And I know that N over V equals P over RT, okay? And so N over V, and I'm just going to take and substitute those numbers in. My pressure I calculated is 1.4622 atm. And when I use my calculator, I just kept all of the digits from the pressure that I calculated earlier. But I'm just writing down one extra. I'm going to divide that by R, which is 0.08206 liters times atmospheres over mole K. Okay, and remember those units, how it goes. And then the temperature at the atmosphere is 93.7 K. Okay, so I've got my pressure, I've got my R, I've got my T. When I calculate this out, atmosphere is going to cancel atmospheres, K is going to cancel with Ks, and this liter times mole is at the bottom. So when I get my number, those units are gonna flip basically, and so I get 0.190. Okay, and this number right here has 3 significant figures, so my answer should have 3 significant figures. But I'm going to carry those on a little bit. So 0.190, 173 moles divided by 1 liter. Okay, so my answer is moles per liter. And when I separate it out, I can just, I can put a 1 in front of that liter and it doesn't change anything. Okay, and since every one of these numbers had to do with Titan's atmosphere, that means I have that many moles of atmosphere. TMOS divided by liters of atmosphere. Okay, so now we want to calculate the density, right? And we want to get to grams per liter. So I have moles per liter. My last step is I'm going to convert that moles into grams, okay? And I'm going to do that with this number right here, and that's that average molar mass of the surface at the atmosphere. So here I'm going to start 0.190137 moles of atmosphere over 1 liter of atmosphere. Okay, and I'm going to use this conversion factor, this molar mass. So if I've got moles of atmosphere on the top, that means my moles of atmosphere go on the bottom. And grams of atmosphere go on the top. Okay, so moles are going to cancel with moles, atmosphere is going to cancel with atmosphere, and when I multiply across, I'm going to multiply this number, the 0.190 times 27.4, and I get grams of atmosphere on the top, divide by 1, and liters of atmosphere on the bottom. So my answer is 5.21, okay, 3 significant figures in both places, 5.21 grams per liter of atmosphere. Okay, so that is how you do that problem. I guess email me if you have any questions or show me what you did, but hopefully that helps.